Good morning, everyone. Welcome to the Tech Talk today. This is the first one of these I've given with a webcam, so we'll hope everything goes smoothly here. The title for today is Managing Revisions to Structural Engineering Models and the Best Practices for Doing that. And I know that when we as structural engineers think of revisions, we tend to think of what happens to the construction documents. But the reality is that we make a lot of changes over the course of projects to analysis models as well. And a lot of times our methods of dealing with the revisions to the analysis models maybe not quite as rigorous as how we deal with those to the construction drawings. As many of you know, and hopefully the reason you're tuning in today, is that we, Bentley, have a framework for dealing with revisions. It acts as the glue in our interoperability between products, and has some wonderful tools built in for managing revisions. That's called Integrated Structural Modeling, or ISM for short. And we will be discussing a lot of the best practices there with ISM today. And we thought it would be a good topic to kind of focus in on some of those best practices, really to get the most out of it, particularly from the revision management standpoint, and also in making sure that we're using it in as simple of a way as possible and not getting bogged down in the complexity of it. Okay. I do have a few slides I'd like to start with. First of all, I wanted to give kind of a high-level look at the ISM. This is kind of the ISM dashboard we show, and all of the ISM-enabled products that are supported in it. And what we're going to focus on today is a workflow specifically between Revit and RAM. Okay, so we're going to look at a situation where we've modeled a structure in Revit from the beginning, and now we want to move one of those stories in Revit over into RAM, and specifically RAM concept. We want to make some changes in RAM concept, and we want to take those changes back into Revit. And one of the themes about today is that there are going to be some of the changes that we make in RAM that are going to be relevant to the documentation environment, and some that are not. Okay, there's some that are just going to be relevant to the structural analysis side of things, and we're going to review some capabilities in ISM that help us be selective about what it is we want to take back into the documentation environment. Okay, so looking at this a little more closely, this is the starting model in Revit here in the upper left. The third story, actually all the levels are a beam and slab system currently. What we want to do is take the third story and evaluate it as a flat slab. Okay, so that's going to mean removing some beams, actually all the beams at the story. It's going to mean reducing the slab thickness or evaluating some different alternatives there. There are going to be some changes. These are the ones I said that are purely analytical, of analytical significance. We're going to want to reshape the slab a little bit, because in this model we happen to have some meshing problems initially in RAM concept. So we need to reshape the slab a bit, add some nodes, reshape some nodes, add an opening. Okay. And finally, we're going to add reinforcing, because we want that to go back over into Revit as well. Okay, so that's kind of setting the stage for what we're going to look at here today. We are not going to cover the entire workflow. We're just going to cover the point in time. If I can go back to the previous slide. What we really want to look at in detail today is the point in time where we've just finished work in RAM, we've done a save, and now we want to commit those changes back into ISM. Okay, so that's what we're going to be looking at in detail here. So let me move away from the slideshow there and bring up ISM. And I have this set up here just at the point in time where we're doing what I just described. For those of you that have not used ISM, a few quick simple things here for a frame of reference. Number one, the right-hand side here, the 3D model, which you can navigate, rotate, query here. The left upper side is the full list of objects that are contained in this model. Okay, and if I select one of these, for instance, a beam element, which in ISM we give kind of a fancier name to, we call it curve member. That's our generic word for beams and columns. If I select that at the lower left, this gets populated with all of the attributes or properties associated with that object. Okay, so basic things like the name, the type of load it resists, and then some analytical properties as well. Okay. Now, maybe the single simplest and most effective piece of advice I can give today in using ISM is this. The first thing I always like to do when I open an ISM model, no matter how big it is, no matter how small it is to go over to the type column up here, right click, and select group by this column. Okay? And what that does is it collapses all the objects, that full list of objects in the model, according to the type of object that they are. And it makes the model much easier to navigate and deal with. As a matter of fact, when I work with an ISM repository, it's rare that I'm ever not in this mode. In other words, I'll expand things, I'll work on it, I'll accept some changes, reject some changes, and then I'll collapse it again like this. Okay, so it just makes the model much easier to deal with. A couple other quick things while we're here that tend to be sources of confusion now and then is that the select all command down here works on every object in the list here, regardless of whether it's expanded or collapsed. Okay, so the select all here is selected all curve members, and then if I expand concrete, we see that that's selected also. And I say this because it's very important to keep track of what objects you have selected, because we might get caught off guard and accidentally perform an operation, accept or reject on an object we're not expecting. Okay. I also like to make frequent use of the clear all command for that reason also. Okay. Okay, so let's proceed with what we set out to do here. And when we're going through this process, the way I further kind of like to divide up the work is to go up to these filters at the upper right here that we can further reduce this list according to objects that were added, deleted, or changed. Okay, and what I'm going to do now is reduce the list just to the objects that were added. Okay, and this is a pretty easy one because over in RAM concept we know we added reinforcing, and that's about it really. Okay, so I would certainly expect when I go up to this list to see a nice long list of rebar objects, and I do. Concentrated surface rebar, and they're currently set to undecided. So what I'm going to do is just select the first one. I'm going to scroll down to the bottom of the list, select the last one, and then just say accept. Okay. Again, I'm going to do a clear all. I like to make frequent use of that. We added rebar, and anytime we add rebar objects, there's also associated material object, so I'm going to accept that also. Okay, and then we see one that we actually don't intend to bring across, and that's that surface member opening I added that was part of the reshaping of the slab that was needed to get RAM concept to mesh, but that I don't need to take back into the documentation environment. So I'm going to go ahead and hit this to reject because I don't want to add that. A quick point here, if we leave things as undecided, those get treated as rejected when we commit them back to ISM. But by saying rejected, we know that it's something that we wanted to flat out not bring over. So it's a little bit of a cue there to us. So I like to go ahead and do that. And then that takes care of the ones that we've added. Okay, so we're through that. Let me turn those off. And now let me turn on the ones that were deleted. And we know that we turned this from a beam and slab system over to a flat slab system. So we would expect a long list of beams to show on here as deleted. Again, curve member is just a fancy way of saying beam or column in ISM. So again, I'll select the first one, the first object in the list, go down to the bottom, shift, select the last one. That selects everything in the list. And I'm going to hit this to accept. Again, do a clear all. Okay, and then we see something maybe a little bit unexpected here. We see that ISM wants to delete the sections that are associated with the beams as well. And this deals with how individual applications interact with ISM. It doesn't seem like we would need to delete those. In other words, if you're using STAAD Pro or RAM Structural System, those products have section catalogs that contain all of the section information in them. But RAM Concept doesn't have that. RAM Concept has beam elements And the section assignment is attached directly to those beam elements. So if the beam element goes, all the beam elements go, then it no longer has this section either. And that's why we're seeing this as a deletion. So this is something I do not want to accept, because we have beams at other stories that still have that section assigned to them. Okay, so we want to keep that. So I'm going to select each of these and hit reject. Again, I'll do a clear all. One other thing on the curve member command, and this brings in some nice capabilities of ISM that help you when you're working with very large models and you kind of want some visual verification as to what you're accepting and rejecting. And that is, I'm going to select these one more time. Select the whole list of objects. And you see that when we select them, they're highlighted, okay, which is nice. Now, what if this was a very large building and we have a list of beams that are scattered all over the place? How can we verify what's going on? Well, you can use this little button down below this pane called Isolate. And that turns off everything except what's selected. So you can see how if this building wasn't quite so neat, wasn't quite so symmetric, was a little harder to deal with, this is a nice way of narrowing down exactly what you have selected there and verifying what you're working on. Let me turn that off and let me go to clear all. Another nice little command, I'm just going to select one beam in the list. And how do we know where that beam is? We know it's highlighted, but it still might be tough to get at. What we can use is the zoom command, another button down here. That'll take us right to where that is. So if I rotate up, that's where that beam occurs. Okay, so you have some nice little tools here that'll help you navigate the model. Okay, so that takes us through the objects that were deleted, and we have one more left. That's those that are changed. Okay, and in dealing with objects that have changed, things can get a little trickier. Let's start with what we know here. We know that we changed the slab at the third level. We reshaped it a little bit. We changed its thickness. But there's some things about this specific change that we want to accept and some that we don't. So we don't want to do a single accept or reject on this whole object. Okay, what we want to do is go down to the list of properties here and be selective about what we're going to change. So if I go to the surface member category down here, I see the change in thickness here from 300 millimeters to 225 millimeters. I'm going to change that to accept. And I'm also going to change the surface offset. I want to change that as well because that affects the reference point and how the thickness of the slab is changed. So I'm going to hit that to accept. And then none of these other ones I want to change. Okay, so RAM Concept added some information into this. It set the bending behavior, some analytical information. It set the bending behavior to two-way. The one that we specifically do not want to accept, if I can find it, there should be a location item here, and it is basically the list of coordinates. There it is, location. This is the list of 3D coordinates that constitute the slab, and this one we specifically do not want to accept. So we can leave that to modified, we can change it to reject, but either way, we have now what it is we want the changes that we want to commit to this model. Okay. There are a couple other things in this list here. Let me do a clear all again. Concrete. Okay, we wouldn't expect any changes to any materials because we didn't make any in RAM Concept. However, Concept does add some information to certain things. It may be relevant. It may be that we want to take these back over into Revit. I happen to not need to take these back over, so I'm just going to leave all these the way they are so that they're not accepted. Nodes, I'm not trying to do anything analytical in Revit, so I'm just going to leave those as is. The curve members show some changes, and that is because they point to the material object, I'm sorry, the section object that was deleted, but that's fine. We're going to go ahead and leave that as it is. Okay, so we're pretty well set up now to go ahead and commit these changes. What I can do to verify that I have everything set the way I need it is, let me rotate the view here so that we're looking up at the slab a little bit. Okay, and what I can do, actually let me turn, this object here is a load and it kind of looks like a slab, but it's not. So let me turn off all the loads in the model here. That makes it a little easier to look at. And what I can do is go to preview, and that will show the new state of the model, and we can verify the changes that we've made. Okay, so we see now that the beams are gone. We're left with a flat slab. It's a little thinner than it was before. If I turn on the display transparent, we can see all the bar in there as well now. Okay, so this looks pretty good. This looks like what we want to commit here. Okay, so that pretty well takes us through the process of managing these revisions and getting things set up to commit back to ISM, and then we're set to read that model pretty much straight away into Revit without many changes. Okay, let me do a quick check on questions. Looks like we don't have any yet, and my colleague John Paul will keep me posted if we do have any there. Couple of other things while we're here. I know that the naming of the objects and the type of objects in ISM tend to be a little non-conventional. Like we said before, we use the term curve member generically to describe beams and columns. We use surface member to describe generically walls and slabs. And the reason for that is we really want to accommodate any type of structure possible. Okay, so we're not just limiting it to buildings. So we tend to need to be a little generic sometimes with the naming, which is why it is that way. But if you want to sort things in a little more friendly manner, the level display is where you can do that. For those of you that are not so familiar with MicroStation, a level in MicroStation is the same thing as a layer in AutoCAD. And in this case, we can turn on and off objects according to their specific type of structural object that they are. So I can turn all the levels off, turn on just concrete beams and columns, and now I've narrowed the model down to just those. And what's nice about this is I can do a select all. And now my list here, again, if I collapse this type, it's reduced to just what I have selected here. So this is another very handy way to reduce the complexity and kind of zero in a little more on specifically what you want to operate on. Okay. Let's see.
Yeah, hi Josh.
Hi John.
Hello. We do have question here.
Okay.
The question is ISM installed with RAM, or is it part of RAM's interface?
Okay, very good. It is part of RAM's interface. As a matter of fact, it's part of the interface really of, let me go back to the slideshow just for a second here. It's part of the interface really of all the products that it interoperates with. In other words, if you go to the file menu of these products, there are ISM options under there, and that's where you write an ISM model, you read one in. Having said that, ISM is not installed with these products. It is a separate installation. You can download it at the same place that you download all of these products. The download itself is called Structural Synchronizer, and as a matter of fact, let's do this really quickly. Let's Google structural. This will take just a second here. Structural Synchronizer. Okay, and actually the very first item that you see here, you click on that, and it takes you right to where you can download it. Structural Synchronizer download from Bentley Store. Okay, so that's where you can download it. It's also available on the fulfillment site where you download all the analysis products, but you can download it here as well if you're not a select subscriber. One more thing to add, if you're not interoperating with Revit, if you are interoperating with Revit, you'll also need the ISM Revit plugin, which is available in the same location. And we also have an ISM Tekla plugin. Okay, so in that case, it's two downloads and installations here. Okay. Okay, so we wanted to say a few words. So these were the specifics of the process. We wanted to say a few words about, to graduate up a level, so to speak, and say a few words about adopting this as a more common procedure in your office, and how to do that, and how to do it with as little disruption as possible. You know, the nice thing about this process as a whole is that actually, let me go back to the slide that I was just on. The nice thing about this is that the look and the interface of ISM is common. So it doesn't matter whether you're interoperating between RAM and Revit like we just were, or if you're using STAAD Pro. This process that we just saw of managing the revisions and updating files is the same for all of those. Okay, they all use ISM. They all link to it. So once you learn it for one set of products, you know it for all of them and all the possible workflows that you could do. A couple of things I would recommend, also if you want to use this process more widely across your organization, make sure you have an understanding of why you're interoperating and what specific information that you want to transfer, right? Because certainly not all of it is relevant. This way you're not spending a lot of time worrying about getting things right that you don't really need to be worried about. Just one example I can think of, we saw that loads is one of the objects that's supported in the ISM transfer. But you may have no need to transfer loads between your analysis application or your BIM applications, or even between analysis applications. So make sure you narrow down exactly what it is you want to transfer and what's important kind of as the final deliverable. I would also highly recommend developing a set of standards for what information you transfer in a given workflow. Put that down on paper, document it. In other words, the little exercise that we just went through right there, you could very easily put together a little document that's kind of a cookbook on what to accept and what not to accept for a specific workflow. Okay, and again, this boils down to what is important, what information do you want to transfer. Okay, finally, I would say make use of the revision history, which is a fantastic feature that is built into ISM. This is the model that we've been working with here, and what I can do is right-click that, and one of the options here is Manage ISM Repository Revisions. And if I select that, it'll take a second here, but it should come up. Okay, we see a list of all of the revisions that have occurred to this model over time. The revision number, who did it, in what application it was done, and then we also can leave a comment as to what happened, which is very important. And what's great about this is each of these is not just a line of text, it's an actual model. So you can go back and view previous revision states. You can recover a previous one. You can see that this model that I was working on, I made some changes to it like we discussed, and then I actually had to recover an earlier version of it so that I had the starting point that I needed for this demonstration. It was really easy to do. So it's, you know, a lot of visibility. This comes back to one of the points we discussed in the beginning, a lot of visibility into how that model changes over time. You can compare differences, and it uses the color coding that we saw in structural synchronizers, so a very useful capability here of ISM. Okay, that pretty much concludes. Yes, John?
One more question here. What other formats does ISM work with?
Okay. Let's go back to the large list of products here supported that are ISM enabled. So in addition to these, ISM can publish to IFC. It can also actually read in an IFC model. So there's two-way interoperability with IFC there. We can publish iModels from ISM. We can, like I said before, we can interoperate with Revit through a plugin. We can interoperate with Tekla through a plugin. So those are the basic formats that are supported. One thing, some of the capabilities in ISM tend to be, we have, I guess, 2 or 3 different executables that run. So some of the things can be kind of hard to find sometimes. The publish to IFC happens to be a separate application. But the way you can find it is to just go to your Start menu in Windows or your search, just type in IFC import, and you'll find that dialog there. I'm sorry, the IFC you can export directly from Structural Synchronizer. I believe it's the import. There's actually a separate application. And a quick word on future development. We are working on consolidating these different applications, the ISM Viewer, the Revision Manager, the IFC import, into a single application. Okay, so it'll be much easier to use in the near future here.
Okay. One more question again, Josh.
Sure, John.
When you export from Revit, okay, to ISM, does it use the analytical model or the physical model?
Okay, so an important point here is that ISM is one model. ISM is not a separate or a dual analytical physical model like Revit is. We do get some confusion there because there are some, if I can bring Structural Synchronizer back up, when we were looking at the level display, there are some things in here that would make you think that it does have a separate analytical model because there's a category analysis. But these are things that are just transferred along with the one model. It's not a separate physical analytical. That being said, we do work on Revit's physical model. That's what we're transferring over into ISM. Okay, so that concludes the portion of the demonstration that I had planned. Okay, one of the questions that we have here, make sure my audio's on. Yeah, okay. What category does a steel brace fall under in ISM? Right, that's a curved member, similar to a beam or a column. Okay, next one. Is there a log or a list on the revision changes made on the model? So if you mean an itemized list of them, no, but right, not in the revision manager itself. But what you can do is you can do a compare between the different states, and then it'll graphically show you, just like on the screen here, added, removed, changed. It'll show all those objects listed here that have changed compared from one revision state to the next. Okay, so it should be pretty obvious there when you use the revision management. Let's see, can you provide a sample standard for ISM data exchange? A starting point would help. So if you mean some some practices or some best practices, like I mentioned earlier, absolutely we can. That'd be a great thing to follow up on. We can post a wiki on that and target it towards a couple different workflows. That's an excellent suggestion. And we generally have follow-up information for you on these tech talks and webinars. We'll post things to a wiki and make sure you know about it, so we'll look to get something out there. Do you find it easier to begin a model in Revit and then transfer that into RAM, or vice versa? I would say that it depends on what type of material it is. For a concrete model, and I would say for a flat slab structure in general, there's really no problem going either way. When you have a model that's steel framed, now you have to worry a little bit more about the connectivity of the individual elements, the beams to the columns, the beams to the beams, and as you know, modeling in Revit or any BIM application, a lot of times, most often the case, you'll model the real-world condition, which means that the beam stops actually short of the column or short of the girder. So that tends to lend itself a little more towards being easier to start in the analysis application in RAM. Okay, I think that's what we're finding in general. Let's see, do you have any tips on how to model objects in Revit to avoid node matching and other geometrical errors, right? Particularly with respect to things like level offset versus Z offset for beams. Probably another topic worthy of a separate follow-up action on our part. We do have lots of, if you go through Bentley communities, we have lots of answers to questions and little wikis that our tech support staff have written that address this. But we'd be happy to consolidate it kind of into one best practices document. I think that'd be a good thing to do. Okay, a couple other questions. What's the difference between ISM and structural synchronizer? No real difference. There just happen to be kind of two names. Really what it is ISM is the platform as a whole, and structural synchronizer that's the name we've given to the product. So when you install structural synchronizer, it installs ISM. And ISM is more than just a product. You can program with it and do things like that as well. Okay, how can I accept a change only if the value exceeds a certain threshold? Meaning I don't even want to see an 1/8" change in column coordinates listed as a change. Right, so we get that request a lot, and I would like to report some things. This gives me a chance to report on something we're working on for the ISM 7 release, which is due out later this year. We're going to add a tolerance setting so that you can control at what threshold objects are seen as having changed. Okay, because right now we're doing a compare on pretty much on exact coordinates, for instance, or other types of values. But by allowing you to specify a tolerance, it'll do just that. If your column is moved only 1/16 of an inch, an 1/8 of an inch, whatever, it won't show that as a revision, which is really going to reduce the clutter, I think, and provide for a smoother workflow. Okay, another one. Is there a way to tell ISM to ignore stories but still keep the connectivity? For instance, if you have a top of concrete level and a top of steel level, there would typically be small column sections in RAM structural system after linking in the ISM model. I might need to think about that one a little bit. And I can follow up with you directly, and we can get into a little more details on that question. Okay. You mentioned that your workflow takes rebar to Revit, but the rebar doesn't go from ISM into Revit. So excellent. I did not clarify this. We're actually currently working on updating our ISM Revit plugin to send rebar from ISM to Revit. It's not in place yet, so I was jumping the gun a little bit in choosing this workflow, but we're looking to have that out as another one of our enhancements in Q3. So you'll finally be able to get that bar that we saw here in the ISM model over into Revit for BIM and documentation. The element grouping is not very intuitive in the way objects are named. Why say curve member instead of beam? Why not just call it a beam, right? So I touched on this earlier. It's basically because we want to keep the system as generic as possible and to handle as many structures as possible, and that's kind of why that naming was chosen. But you're right, curve members are rarely curved. They're usually just straight beams, braces, and columns. But we at least do have the label, which tells you what specific type of engineering building-friendly object it is. Okay, Ellie, I think we're current on questions. We do have some follow-up, like I said, to do. We'll take care of that, but I think that's it from my end.